See this question. Consider the following relations. So they have given four relations, R1, R2, R3 and R4, and the question is which of the following, which of these R1, R2, R3, R4 are equivalence relations. So the question is we have to find out which one of these four are equivalence relations. Okay, so it is asked in GATE 2001. So whenever such a question is given, it is better that you analyze it. There are two ways to prove. Okay, better I'll take the examples and I'll solve it. There are two ways to prove in general. One is if you can directly prove it using the variables a, b, it is okay. Otherwise, if you feel that one of the property is not going to be satisfied, it is always better that you form a counter example. So there are two proofs. One is you can directly prove by taking the variables, some general variables a, b or a, something like that. Other way is by taking the counter examples. So now here I am going to use these two methods to prove them. Okay, so just see this. First one is R1. So relation R1 is containing ordered pairs a comma b if a plus b is an even number over set of all integers. So we have already seen this earlier, so but then I'll just prove it again. So first of all you have to show that it is reflexive, symmetric and transitive. So what can we say about reflexivity? So if I take two integers and if the two integers are same, which means a comma a, so will all such pairs belong to the relation R1? So will they belong? Yes, they belong, because if you add a plus a, then it is sum is going to be 2a, and of course it is going to be even. Therefore what can we say? That it contains all the diagonal pairs, because sum of every two terms in the diagonal pairs is an even number. Therefore it is reflexive. What about symmetric? If you find out that a plus b is an even number, then you can even show that b plus a is also even number, and therefore if a comma b belongs to R, then b comma a will definitely belong to R. Therefore it will contain all the symmetric pairs in case if they are present. Therefore we can say that it is symmetric. What can you say about transitivity? If you can see that a plus b is an even number, and then if you see that b plus c is an even number, then what can you say about a plus c? So let us say a plus b is an even number, let's say it is 2k, and b plus c is an even number, let's say it is 2l. Now let's add everything together. So if you add everything together, then what do we get? A plus 2b plus c, which means I am adding these two terms, will be equal to 2 into k plus l. Right, now what can we say about a plus c? A plus c equal to 2 into k plus l minus b. So what can we say now? A plus c, sum of these two elements a plus c is going to be an even number, isn't it? It is a multiple of 2. So therefore a comma c will also belong to the relation. If a comma b belongs to the relation, which means a plus b is an even number, and b comma c belongs to the relation, which means b plus c is an even number, then a comma c will also belong to the relation, which means a plus c will be an even number. Since a plus c is an even number, definitely a comma c will belong to it. Therefore we can say that R1 is definitely equivalence relation. Now what can we say about R2? R2 is saying that R2 will contain two numbers a comma b only if a plus b is an odd number. Okay, what can you say about it? So we have to prove all this: reflexive, symmetric and transitive. Let's try to prove reflexive relation. Now will the items of type or the elements of type a comma a belong to R2? So just add them. A plus a is going to be even number, not an odd number. Therefore the elements of type a comma a will never be present in this relation, because they are not going to be, sum is not going to be odd, sum is even. So since we cannot add the diagonal elements into the relation, we can say that it is not reflexive. Since it is not reflexive, we can say that it is not equivalence relation. Therefore R2 is not equivalence relation. Now let's look at R3. R3 is saying that R3 will contain elements of type a comma b if a into b is greater than 0 over set of all non-zero rational numbers, which means we can take any number which are not rational. Okay, so you can take any rational number which is not 0. any rational number which is not 0, right? Therefore, if you observe this, if you take any two numbers, rational numbers of type a into a, either they will be positive, either a will be positive or a will be negative, and if you multiply them, product of two positive numbers is going to be positive and product of two negative numbers is also going to be positive. Therefore, you take any two numbers, any two rational numbers, the product is always going to be positive, so all the diagonal elements will belong to the relation R3, and so we can say that it is definitely reflexive. What can we say about transitivity? Symmetric. Let's talk about symmetric now. If a comma b belongs to R3, which means a into b is greater than 0, then definitely b into a will be greater than 0, and definitely b comma a will also belong to the relation R3. So what can we say? If a comma b belong to the relation R3, then b comma a will definitely belong to the relation R3, and so we can say that the relation is symmetric. Therefore, R3 is reflexive and symmetric. Now let's see transitivity, whether it is transitive or not. Now let us say a comma b belong to R3, which means a into b is greater than 0, and let's say b comma c also belong to R3, which means b into c is also greater than 0, right? Now let's take the product of these two numbers. This is a positive number, this is a positive number, isn't it? It is greater than 0, it is greater than 0. Now let's take the product of these two numbers. What should it be? If these two are positive numbers, product of two positive numbers should always be positive. Therefore, if I take the product, then it is going to be a into b square into c, which is greater than 0, which means it is going to be positive number. Now, anyway, b square is always positive, isn't it? B square is definitely going to be positive. Therefore, we can say that a into c is definitely positive. Are you understanding this logic? See, this is positive number because a comma b belongs to relation R3, and this is positive number because b comma c belongs to relation R3, and now these two are positive numbers, a into b and b into c, and when I take the product, that should be positive. That is why I am writing like this. And we know that b square is already positive number, so definitely if this is positive number, then the remaining product a into c should also be positive. Therefore, a into c will definitely be positive, and so a comma c will definitely belong to the relation R3, and so it is transitive as well. It is reflexive, symmetric and transitive. So what can we say? It is definitely equivalence relation. R1 is equivalence and then R3 is equivalence. Now let's talk about R4. So R4 is saying that it contains all the ordered pairs a comma b if det of a minus b, let's say modulus of a minus b is less than or equal to 2, which means it will contain all the pairs whose difference is not greater than 2. That is the meaning of it. If you take any two numbers and if you take the difference between them, it should not be greater than 2. If it is less than or equal to 2, then we are going to have them in the relation. Right? Now let's see whether it is equivalence or not. Let's see whether it is reflexive or not first. So how can we show that it is reflexive? We should show that all the diagonal elements of type a comma a will be present in the relation R4. How can we show them? If they follow this property. Right? If a comma a has to belong to the relation R4, then the difference between a should be less than or equal to 2, isn't it? Now we got 0 and it is less than or equal to 2, therefore all the diagonal elements will definitely be present in R4. So we can say that R4 is definitely reflexive. Now let's talk about symmetric. Now what does symmetric mean? If a comma b already belongs to the relation R4, then what does it mean? A minus b is less than or equal to 2. Then since it is a whenever you apply this modulus, then we are going to have positive numbers only. So I can write it as b minus a also. It doesn't change anything. So if a minus b is less than or equal to 2, then b minus a is also going to be less than or equal to 2 because we are taking the modulus, right? So what can we say about it now? So we can say that if a comma b belongs to the relation R4, then b minus a will also be will also belong to the R4. So it is symmetric. And now let's try to see whether it is transitive or not. How can we test it? So let us assume that we have number. Okay, so here I think I am going to use counter example principle. So intuitively I feel that it is not going to be transitive, because if difference between two numbers is 2 and the difference between other two numbers is 2, it doesn't mean that the difference between these two numbers is going to be 2. Okay, so I'm not sure whether you got it. So what I'll take is, in order to prove this, in order to prove that it is not going to be transitive, I'll take a counter example. Okay, so whenever you want to prove that something is wrong, best way to do it is by taking counter example. But whenever you want to prove it so that something is right, then you cannot give an example, because it has to be true for all the examples. Therefore, when you are trying to prove that something is right, you better give a generic solution. If you are trying to prove that something is wrong, you just give a counter example. Now here I want to give a counter example. Okay, now let us say I'll just come up with some numbers. How am I doing this? Just with intuition. That's it. I'm just feeling that it might be right. That is intuition. So with lot of if you watch all these videos and if you practice some questions, you also will develop that intuition to answer that questions quickly. Okay, now see this. I know that, I feel that, see 1 comma 3, let's say 1 comma 3, what can you say about this pair? Will it belong to the relation R4 or not? It will definitely belong to the relation R4, isn't it? Why is that so? Because if you take the difference is less than or equal to 2, therefore it definitely belongs to the relation R4. Now if you take 3 comma 5, it will also definitely belong to R4, because if you take the difference is going to be less than or equal to 2, difference between 3 and 5. Now what can we say about 1 comma 5? The difference is not less than or equal to 2, the difference is 4. Therefore, even though 1 comma 3 and 3 comma 5, these two belong to the relation R4, 1 comma 5 does not belong to the relation R4. So we can say that clearly this relation R4 is not transitive, and when it is not going to be transitive, we can say that it is not equivalence relation. Got it? So in this example, in this question, R1 and R3 are equivalence relations, R2 and R4 are not equivalence relations. So this is how you are supposed to analyze. See, just since I am explaining this question right from basics, it took so much time, but then if you are answering it in an exam, it will not take more than 1 minute. You can just directly look at the question and you will be able to guess whether it is equivalence or not. So don't worry about the time. You will have enough time. You will have a lot of time in the exam. You can even do it slowly. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.